Good day, everyone. This is a Maths Intellectual tutorial sponsored by Mathematical Intelligence, and today we are going to be looking at Cramer's rule. And Cramer's rule is just like a rule we use, a method we use to solve system of linear equation. It's just like a method we use to solve system of linear equations. So this method is really useful when you have maybe a simultaneous equation or a system of linear equations that you're trying to find your known variables. I get it now. So this is also a continuation of the series, the previous series on matrices. So let's write on for today and see. Let's look at an example. Let's look at an example. Let's say we have given, let's say we are given 2x, are we there? Plus 3y, are we there? Equals to 7. And we are also given x plus, let me see, minus, make it more, minus 2y equals to minus 3. And then we are asked to find x and using Cramer's rule. So we have to find x and y using Cramer's rule. So how do you find x and y using Cramer's rule? Very simple, very easy. First of all, we need to convert this to a matrix. From this is the system of linear equation. You are trying to find value of x and y. You know that we can use, there are different methods we can use to solve these questions: elimination method, substitution method, graphical method, Gaussian elimination method, different kind of method. But just for today, you are using Cramer's rule, and Cramer's rule is very simple, very easy to um, solve such problem. So let's see how it goes. So first of all, we need to convert this to a matrix form. Let's say we have something like converting it to a matrix form. Let's say we have, it will become something like 2 3, I get 1 minus 2. These are the coefficient of x and y, and then we have x, we have y equals to, we have 7 minus 3. Do you get it now? Because yeah, if your rule multiply your colon, you get equation 1 here, and this second row too, if this row 2 multiply this column 1 again, you get this, and you get this back. So this here is the exact same thing as the equation on top. I get it, so I didn't change anything from there. All right, so this is our problem here which you are trying to solve. So let's name this matrix here, which are the coefficients of your this thing or your known variables. Let's name it A. Let's say this is a matrix A. So let's say this is matrix A, and we are trying to solve using Cramer's rule. So first of all, the formula here, which is, there are different terms they use in textbook. I'll just use one I like using. I'm looking for the value of my x and y. So for the value of my x, what I just do is, was my x is equals to determinant of a subscript x over determinant of a. I don't know. My y is also determinant of a subscript y by determinant of a. So I'll tell you what this determinant of a subscript in some tests they use d1, d2, they use dx and the likes, and that d stands for determinant, so they don't put this determinant there. I get it now. So let me quickly do this. So this is my a. What is my ax and what is my ay? Let me search for ax first. What is my ax? So my ax is, this is the coefficient of x. I don't know. This is the coefficient of x, because when I expand this, I'll get out my matrix 2x. I get it now. I get my matrix 2x plus plus so y, like that. I get it now. So, and this is my coefficient for x. So since this is my coefficient of x, I'll remove it and I'll put this one there. I get it now to get my ax. This is my matrix A. I'm going to remove the coefficient of x, which is 2 and 1, and add my constant term there. I get it now. So that is exactly what I'm going to do here, and you see it for yourself. So my ax will now be let me use bracket, that will be 7 minus 3. I get it now. And then that is the one I removed, and then we have 3 and 2. I get it now. So you have 3 and 2. I get it now. So we have 7 minus 3. I remove this 2 and 1 and put 7 minus 3 there. So that will be my ax. I get it now. So what is now my determinant of ax? My determinant of ax and also my determinant of a. So what's my determinant of a? That's 2 times 3. Do you remember? That will be something like 2 times 3. 2 times 7 times 2 rather, and 3 times minus 3. 7 times 2 will give me 14. 7 times 2 give me 14, and that will be minus, so that is 14 minus 3 times 2. 3 times minus 3, that will give me minus 9. That's minus 9 times this will give me plus 9. Are you there? So equals to, this will give me 23. So this is my determinant of ax. So what's my determinant of a there? So what's my determinant of a? So what's my determinant of a? That will be 2 times minus 2 and 3 times 1. That's 2 times minus 2 will give me minus 4. So will give me minus 4. Sorry about that. Minus 4. I there. Minus 3 times 1 will give me 3. So that will give me minus 4 minus 3 will give me minus 7. So this is my determinant of a. I get it now. Okay. So what is now my y? You know my y is what? Determinant of ay over determinant of a. So what is ay? So yeah, first of all, let me finish my x. My x will be, what is determinant of ax here? That's 23. Okay? Over determinant of e, that is minus 7. So you have 23 over minus 7, that's my x. So what about ay? So my ay here will be removing every coefficient of y, and then from this place my ay will be removing all the coefficient of y. This is equal to the coefficient of y here, which is same thing as what we have here. Can you see it now? Which I convert to matrix. I'll now put my constant term there. So what do I have when I remove that? We have 2 1, then I have 2 1, I have 2 1, and then removing that coefficient of y, which is 3 and 2. I'm putting 7 and 3 there. That will be 7 and 3. Then we put that in another marker, 7 and 3, which is this. I get it now. So since this is our ay, so what's the determinant of ay here? So from here, what's the determinant of our ay? Our determinant of our ay will be equals to 2 times 3, that will be 6, minus 7 times 1 is 7, which will give me minus 1. I did not. So if my determinant of ay is minus 1, so what is my y? So my y is depth of ay over depth of a, as determinant of a. So what is the determinant of a? Minus 1. What is the determinant of a? What is the determinant of a? That's 7. That would be minus 7 rather. So this and this give me 1 over 7. So which does gives us the value of y. So in this equation, the value of my x is minus, that's 20 over minus 7 and 1 over 7. So and this explain what this gives us the solution to this problem. So there's nothing there. So you can try other examples and see if you can. All you just need to do is get your ax by removing the coefficient of a and putting the constant, find determinant of a, divide it, you get your answer. Do the same thing for y. If it is 3 variables, do the same thing for x, y, and z. That will be a 3 by 3 matrix. That means you have to solve 3 by 3 matrix determinants. That's why We've done determinant in the previous video, and if you have not watched that, make sure you go and check it out. So don't forget to also like, subscribe, and share this video. I'll see you next time.